Last stage we ranked features and cut the noise, but we've been chaining impute, encode and scale by hand every single time, and one slip leaks the test set. Today we put the whole chain inside one object. A pipeline is just a list of named steps. Step 1's output becomes step 2's input. Nothing skips the line. Here's the magic. When you call fit, each step learns its numbers from the training data only. The imputer learns the train median. The scaler learns the train mean. When you call transform on the test set, the data walks the same steps, but reusing the numbers already learned from train. The test set never teaches the machine anything. That's why a pipeline kills leakage by design. You literally cannot fit on the test set because fit only ever sees what you hand it, and you hand it train. Let's build the smallest real pipeline, impute the missing total charges, then scale. 2 steps, 1 object. First we load telco, coerce total charges to numeric so the 11 blanks become anon, and pull out 3 numeric columns to keep this clean. Then the cardinal rule, split before anything else, stratified on churn, random state 42, train teaches test only gets graded. Now the pipeline itself, a simple imputer with the median, then a standard scaler. 2 named steps in order. We call fit on the training data. The imputer memorizes the train median. The scaler memorizes the train mean and spread. 1 call, both learned. Then transform the test set through the same fitted pipeline. Test rows get imputed with the train median and scaled with train statistics, 0 leakage, and we print the proof. 1 object, 1 fit, leakage gone, but telco has numeric and categorical columns that need different treatment. Next, routing each type down its own branch with column transformer. If this helped, like and subscribe for more.